The first question is, what is the equation written in vertex form of a parabola with a vertex of -5, -4 that passes through -7, 8? So let's first talk about what vertex form is. Vertex form, if you recall, is y equals a times x minus h squared plus k. I'm given the h and the k, right? So in order to write the vertex form, I need the a, the h, and the k. I already have the h and the k, so I'm going to substitute -5 in for h and -4 in for k. So when I go and write that, I have y equals a times x minus a -5, so plus 5, and then plus k is -4, so minus 4. What I don't know is the a, so we'll have to figure that out. But if I go and look at the answer choices at this point, I already know that it's plus 5 on the inside and minus 4 on the outside. So it could be answer choice A, it could be answer choice B, because they both have plus 5 on the inside and minus 4 on the outside, but it's not going to be C, and it's not going to be D. Okay, so I already know that off the bat. In order to figure out the A value, I'm going to use the other point and substitute that in for X and Y. So -7 in for X and 8 in for Y. And then I'll solve for the A that I need. So 8 is equal to A times -7 plus 5 squared minus 4. So I have 8 is equal to A. -7 plus 5 is -2 minus 4. -2 squared is 4. So I have 8 is equal to 4A minus 4. I'm going to add 4 to both sides. I get 12 is equal to 4A, divide both sides by 4, and I get A is equal to 3. So when I go and put it back together, I get Y is equal to 3 times X minus a -5, so plus 5 squared minus 4. So that is answer choice B, ends up being the answer here. Okay, so if you have a vertex and you have an extra point, that's the process to get the equation in vertex form. Let's look at number 2. Function g is a transformation of the parent function f of x equals x squared. The graph of g is a translation right 5 units and up 1 unit of the graph of f. Write the equation for g in the form y equals ax squared plus bx plus c. In other words, get it in standard form. So we're actually going to use vertex form to start, and then we'll convert it. So a couple things to point out. So parent function is f of x equals x squared. That has an a value of 1 because there is no coefficient on the x squared. If the parent function had a 2, so like 2x squared, then the a value would be 2, but this one doesn't. So a is 1 for our function as well. And then it says, well, the parent function is f of x equals x squared. It has a vertex of 0, 0. If I moved 0, the vertex, if I moved this function 5 units to the right and 1 unit up, the vertex would be here. And the vertex would be 5, 1. So that means the h value is 5 and the k value is 1. So when I go and write that equation, it'd be y equals 1 for 8, so I don't need to write that anymore. And then x minus 5 squared plus 1. Again, it's negative inside when you're moving right. If it was moving it left, the coordinate would be negative on the graph, and then it would be positive in the equation, right? If it was moving down, then the number on the outside would be negative. So now I'm just going to convert this into standard form. So what I'm going to do, remember, a binomial squared is to FOIL it together, FOIL it with itself. So we're going to multiply x minus 5 with x minus 5. That plus 1, we're going to leave out there till the final step. So x times x is x squared. X times -5 is -5x. -5 times x is -5x. And then -5 times negative 5 is positive 25. And again, that plus 1 is out there. Now I'm going to combine like terms. X squared stays x squared. Negative 5x and negative 5x will combine to negative 10x. 25 and 1 will combine to 26. So your equation is y equals x squared minus 10x plus 26. C is your answer. Next one gives you an equation and asks, what is the vertex? So y equals x squared plus 10. What is the vertex of that? We're going to go quickly over two ways to do that. First of which is use Desmos. Just use Desmos. It'll show you where the vertex is, and that'll be your answer, right? So let's get rid of that one. All right, so y equals x squared plus 10. The vertex is at 10, 0, 10. So the answer is going to be 0, 10a. If I go to do this algebraically, which again, you can use Desmos on the test, so that is a fine way to do it. But if you were to do this algebraically, recall that the formula for that is x equals the opposite of b over 2a. This is a little tricky because there is no b value, right? So remember, the a value is the leading coefficient. So in this case, it'd be 1. There is no linear term, so the b value is 0. And then c is 10, although you're not going to use that for this. So since b is 0, there is no negatives, it's just 0. So 0 is the numerator. 2 times a is 1, so 2 times that would be 2. 0 divided by 2 is 0. So the x coordinate is 0, like we saw on Desmos. And then in order to get the y, we're going to substitute the 0 in for x. You get 0 squared plus 10, so that's 10. So the y coordinate is 10. So again, like we thought, a is your answer now. So 0, 10 is your vertex. So you can find the vertex algebraically or on the graph. All right, number 4. The path of a projectile launched from the top of a 10-foot tall tower is modeled by that equation, which is the correct graph of the equation. So we're going to just graph it on Desmos and then see which graph matches it. However, we can eliminate 2 answer choices in a second because, well, first of all, the context is the rocket's launching from 10 feet up. Looking at the equation, that 10 is reflected in the y-intercept. So that means 0, 10 should be a point on the graph. So if I look at answer choice A, 0, 10 is there. So it looks like A could be the answer. 0, 10 is here for B. So it looks like B could be the answer. And then looking at answer choice C, 0, 10 is there, not matching that graph. So C is out. And then also for D, it does not cross through 0, 10. So D is also out. So it's really just between A and B. When I graph this on Desmos, I'm going to look for the vertex and the x-intercept. So for answer choice A, that looks like the vertex is at 126. And then it looks like the x-intercept is at maybe 2.25, something like that. For answer choice B, that looks like the vertex is at about 1.5, and I don't know, maybe about 36. All right. And then it looks like the x-intercept's at 3. So when I graph this on Desmos, one of them should appear like it's the answer more than the other, right? So maybe those numbers aren't exactly right, but one of them will definitely be closer. So the equation was negative 16t squared plus 32t plus 10. We'll just use x on Desmos, but it means the same thing. So that should have been 32. Okay. We'll zoom out so you can see a little better. So vertex is 126. So actually that was exactly like answer choice A. And then 2.275 is just slightly more than 2.25. So that also looks like it's the answer in terms of it being answer choice A. Okay. Then the second part of the question is the path of the projectile launched from the top. Well, same information. What is the maximum height in feet reached by the projectile? So the maximum height is the y-coordinate of the vertex. So the y-coordinate of the vertex is 26. So the rocket reaches 26 feet before it starts coming back down. That 1 represents that it took 1 second for the rocket to reach its maximum height. It's not what the question asked for. It asked for the 26, but that is how you would get that if it was asking for that. And then the x-intercept represents how long it takes for the rocket to then reach the ground. So 2.275 seconds from when it launched. So 26 is your answer, though, after saying all that. 26 feet is the maximum height reached by the rocket. Any question that's giving you the equation of a curve and it asks for what is the highest point of the curve, whether it's a rocket, whether it's a ball, whatever, it's the y-coordinate of the vertex. All right. The x-coordinate of the vertex is how long it takes to reach that maximum height. And then the x-intercept will represent how long it takes for the object to reach the ground, if the ground's at 0. All right, number 5. This question I'm going to take out of the test because it really does require you to have a graphing calculator for. You cannot do this one on Desmos. And I haven't taught you a different way to do it. So it wouldn't be fair for me to leave this question in because I know some of you have graphing calculators, some of you don't. So we're just going to take the question out. I'm going to show you how to do it real quick, just so that way we did review it in case you will see this again maybe in the future. But again, I will be taking this question out of the test in all fairness. So in order to, we're going to do the quadratic regression on our graphing calculator. You hit the stat button, and then you just hit enter on edit. Then you type in the x values from the table in L1. So that's what I have there, 0, 10, 20, and 40. And you type in the y values into L2. So 32.4, 20.1, 5.8, 75.6. Once you have that information into the stat table, you're going to quit out by hitting second, quit. Then you hit that stat button again, go over to the calc column, and the 5th thing down is the quadratic regression. So I'm just going to hit 5 and then hit enter. And then it gives you, rounded out to many decimals, the A, B, and C values of the equation that goes through those points. That's what a quadratic regression is. The equation that will go through those points as close as it can get. So it says round to the nearest hundredth, so 0.108 will round to 0.11. So it's looking like A is your answer. Negative 3.36, that matches the B value there. And then for C, 35.2, that 4 will round to a 5, so 35.25. So A is your answer there. So that would be answer choice A. Again, I'm not going to make you do this on the test because not all of you have your graphic calculators at home. If we were in class, you would obviously just borrow mine, but in fairness, we will take that question out. Number 6, solve the equation x squared minus 18x equals 40. And you got 3 options to solve an equation like this. You can graph it, and on the graph where the x-intercepts are would be your answers. So you could use Desmos to solve this. You could also use quadratic formula. You would just subtract the 40 over and then find the A, B, and C. We have some examples that we'll do of quadratic formula in a few moments. The other option here is to solve by factoring. I'm going to do factoring because looking at the answer choices, they're all integers. So assuming one of those answers is the correct answer, which must be, I know that this is factorable because the answer has to be an integer, right? So I'm going to subtract 40 from both sides. You get x squared minus 18x minus 40 equals 0. Now I'm going to factor that trinomial. It is a trinomial with no leading coefficient, so I'm going to unfoil it. So I'm looking for the factor pair that multiplies a negative 40 and adds a negative 18. I also know that if that's x squared there, I just go x here and x here. Since I'm multiplying to a negative, signs will be opposites. If I have negative 40 as my third number, I'm looking for the factor pair of negative 40 that adds a negative 18. So I'm going to start with factor pairs of negative 40. So 1 and negative 40, I'm going to start with. The negative is going to be the bigger number because when I add these, I have to get back to a negative as well. If that 18 was positive, I'd be putting the negative on the left side of the table. But 1 and negative 40 add the negative 39. So that doesn't match negative 18, so it's not that. So let's try 2. Negative 40 divided by 2 is negative 20. 2 and negative 20 add to negative 18. So that is our answer. Well, I'm sorry, it's not the answer to the question, it's the answer to our factoring. So 2 goes in there, negative 20 goes in there. If that wasn't the pair, I would just keep going until I got the pair that worked, all right? Once I have the factors, though, in order to get the solutions for the actual question here, you have to set the factor equal to 0. So x plus 2 equal to 0, subtract 2, and you get x equals negative 2. All right, x minus 20 equals 0. I'm going to add 20 to both sides, and you get x is equal to 20. So x equals negative 2, x equals 20, B is your answer. All right. Again, you could solve this quadratic formula. You could solve this by graphing. I think factoring is probably the easiest way to do it, but it's up to you. And that's the thing about some of these questions where you can solve it multiple ways. I don't know. I'm not going to know. Nor would I care. I care if you get the right answer. So if you want to try it a different way than what I'm describing, you can go for it. All right. This question is saying a ball is thrown from the top of seats in a stadium. The function h of t gives the height of the ball t seconds after it is thrown. How long will it take before the ball hits the ground? This is actually a pretty similar setup to the rocket going up and coming down, although it's asking for a different part for the answer. So let's say up here is 96 feet. The ball's going to do something like this and come down, right? So the question is, how long will it take? If I can find that x-intercept, the x-coordinate of that x-intercept, so the x-intercept, is going to be the amount of time it takes the ball to go from here to here. So I essentially need to solve the equation. So again, you have the same three options. You can solve by factoring, which I don't know if that's going to work or not, given the equation that I'm looking at. I can try quadratic formula, which again works great. We'll practice that in a few questions. You can also solve by graphing. So I'm going to look at the graph on this one. When the questions are in context, I think graphing makes a lot of sense. So negative 16t squared. So I'm going to leave it as 16x squared plus 16x plus 96. Let's zoom out here a little bit. So the vertex is here, 0.96. That's the point at which the ball is thrown from that high up in the stadium. Then the ball goes up a little bit to the vertex. So the ball goes up to 100 feet up in half a second, and then it comes all the way down, and it lands at 3 seconds. So at 3 seconds after the ball is released, the ball is now on the ground. So it took 3 seconds. The x-coordinate of your x-intercept, so in this case, it's 3. So 3 is your answer. If you solved it by quadratic formula, you would get 2 answers. Negative 2 would be your other answer. In the context of this question, the negative doesn't make sense because that would be representing going back in time, and the ball's not going back in time. So 3 is your one answer to this question. So just type in 3 for that. All right, identify the interval on which the function y equals negative x squared plus 5x plus 14 is positive. So we're going to graph this as well on Desmos, and then let's just graph it, and then we can talk about where is the function positive and where is it negative, and how can you tell? So negative x squared plus 5x plus 14. Oops. Okay, there we go. Let's zoom back in a little bit. This graph is positive when it's above the x-axis. It's negative when it's below. Okay, so that's what positive and negative of graphs are. So if I'm interested in where is it above, I want to know where is it crossing, right? So it is positive between -2 and +7. All right, so I go and look at the answer choices. It is positive between -2 and +7. So D is going to be your answer here. Go back and look at it again. It is negative when it's below. So this question wasn't asking for it, but if it did, it'd be negative infinity up to -2 is where it is negative here. And then from 7 to positive infinity, when we're talking about these intervals, it's the x values that I care about. So 7 to positive infinity would be also where it's negative. But again, your answer for this is D. All right, number 9, use square roots to solve that equation. So I have x squared equals -100. We're going to take a square root of both. And then I have x is equal to plus or minus square root of -100. Square root of -100 I can simplify by splitting -100 into -1 and into 100. The -1 will come out as I. The 100 will come out as 10. So x is equal to positive or negative 10i. So x is equal to 10i and negative 10i. When the question says select any solutions that apply, that means there might be more than one answer. It means there's probably more than one answer. So you've got 10i and you've got negative 10i. So you would check both of them. The other thing you can tell is that the answer choices are all squares. And answer choices that are squares have more than, you can click more than one. When they're circles, you can only click one. When they're squares, you can click more than one. In this case, 10i and negative 10i. Write the product of 3 plus 3i and 3 minus 3i. So we're going to take these complex numbers and multiply them together. One thing to note is that these two numbers, 3 plus 3i and 3 minus 3i, they are conjugates. They are conjugates because they are the same terms and the signs are opposite. So they both have 3 and 3i, one's plus, one's minus. When you multiply conjugates together, what we learned is that the imaginary number eliminates and you're left with a real number. So at this point, since I know multiplying conjugates together, I know my answer is going to be real. So it can't be C or D. All right, it's going to be either 18 or 0. So let's FOIL this together and see what happens. 3 times 3 is 9. 3 times negative 3i is negative 9i. 3i times 3 is positive 9i. And then 3i times negative 3i is negative 9i squared. When I go to simplify now, that negative 9i and the positive 9i inside, that adds to 0. And then I have 9 minus 9i squared. I squared is equal to negative 1. So that negative 1 I'm going to substitute in for I squared. I have 9 minus 9 times negative 1. Negative 9 times negative 1 is positive 9. So 9 plus 9 is 18. So answer choice A here And you can see how easy it would be to flip a sign and get 9 minus 9 somewhere and get 0 as your answer. Just be careful for a question like this. All right, number 11. All right, so 25 divided by 4 plus 3i. When you're dividing complex numbers, you cannot leave an imaginary number in the denominator. So we're going to simplify this by turning that imaginary number into a real number. And what we're going to do is essentially what we just did, which is multiply it by its conjugate. So 4 minus 3i is the conjugate. What you do the denominator, you do the numerator. So let's multiply them together. 25 times 4 is 100. 25 times negative 3i is negative 75i. That's all divided by. I'm going to FOIL these together. 4 times 4 is 16. 4 times negative 3i is negative 12i. 3i times 4 is positive 12i. Those will add to 0. That was the whole point. And then 3i times negative 3i is negative 9i squared. So you have 100 minus 75i. The middle terms, they add to 0. And then the I squared turns to negative 1. So you have 16 minus 9 times negative 1. So it's really like 16 plus 9, which is 25. So you end up with 100 minus 75i divided by 25. If you can divide out a 25 from each of the 100, the 75, and the 25, you need to do it. So dividing a 25 out of that, you get 4. Dividing 25 out of negative 75i, you get minus 3i. And dividing 25 out of 25, you get 1. So your answer is 4 minus 3i. So your answer is B. Okay? So answer choice B for that one. All right, factor this expression. So one of the first things we talked about when we did difference of squares is that it only works when it's a square minus a square. But then we talked about imaginary numbers. And you can do a square plus a square if you convert this into a difference, right? So I can turn positive 9 into minus 9 times negative 1, right? Negative 9 times negative 1 equals positive 9. That negative 1 I can turn into I squared. So I can say it's 4x squared minus 9i squared. Now this is a difference of two squares. It's imaginary, but it is a difference of two squares. When I go to factor it now, I'm going to factor it just like we learned how to do a difference of two squares. 4x squared, square root of that is 2x. Square root of 9i squared is 3i. And then 1 would be plus, 1 would be minus. So this factored is 2x plus 3i and 2x minus 3i. Answer choice B just has your binomials in a different order, but it is the same. 2x minus 3i and 2x plus 3i. We're going to solve this one by completing the squares. One of the things I talked about earlier was if you have multiple ways to solve something, you don't necessarily have to do it the way it's asking you to. I'm going to solve this by completing the squares, so that way we cover how to do that. But if you'd rather do quadratic formula, you could try that. Graphing would only work if they're real. So if the answers are imaginary, it's not going to work. Quadratic formula would work, obviously, because that works for everything. Factoring only works if it's factorable, so you could try that, but if it's not factorable, that wouldn't work. So I think your options for this one appear to be, based on the answer choices, completing the square or quadratic formula. But I'm going to do completing a square. So the first thing I'm going to do is subtract that 17 to the other side. I get x squared plus 8x equals negative 17. I'm going to complete the square based off of that 8. Whatever the b value is how you complete the square. So you take that number, in our case it's 8, we're going to divide it by 2 and you get 4. Then you take that 4 and you square it and you get 16. So 16 is what you're going to add to each side to complete the square. So now you've got x squared plus 8x plus 16 equals negative 1. X squared plus 8x plus 16 is a perfect square, and that can get factored by taking the square root of the first term and the square root of the last term and the sign of the second term and making it squared. So now I have x plus 4 squared equals negative 1. Let's take a square root of both sides. X plus 4 squared, when you take the square root of it, you get x plus 4. And then square root of negative 1 is plus or minus square root of negative 1 is I. So now I'll just subtract 4 to the other side, and you get x is equal to negative 4 plus or minus I. So you get negative 4 plus I and negative 4 minus I. Those are your two solutions, and that appears to be answer choice A. So answer choice B just has the negative flipped, so that'd be an easy mistake to make somewhere. C and D, not sure exactly how we make those mistakes, but well, looks like the 33 you would get if you made the 17 positive. Anyway, answer choice A for this one. Let's try number 14. All right, a function is defined by the equation y equals x squared plus x plus 1, which statements are true. All these statements, if you read them, all have to do with the graph. So let's just graph this equation, and then we can better answer those questions or say if those statements are true or not. So x squared plus x plus 1. All right, so that is that graph. So let's read the first statement. The first statement says the graph of the function opens downward. That is clearly opening upward. So A is a false statement. Part B says the range of the function is all real numbers. So the range refers to the y values. Every parabola either opens up or down. So its range will not be all real numbers. Its range is limited either by, in this case, let's see, the vertex has a y coordinate of 0.75. So its range starts at 0.75 and then does go forever, but is not forever in both directions. If the question was, or the statement was, the domain is all real numbers, that would be true. Every parabola has a domain of all real numbers, but none of them have a range of all real numbers. So that statement, B, is false. C, the equation written in vertex form is y equals x plus 1/2 squared plus 3/4. The x coordinate of the vertex is negative 0.5, which is negative 1/2. So x minus negative 1/2 would be x plus 1/2. So that part of the equation matches. And then the y coordinate is 0.75, which is 3/4. So plus 3/4 also matches. So C is true. And then D, the graph of the function has a minimum of 3/4. So since this graph opens up, the y coordinate is the minimum value. If it was opening down, it would have a maximum value, but this one has a minimum. So that statement is true. Y equals 3/4 is the minimum, and it's at a value of x equals negative 1/2. So negative 1/2 is the x value that's at. So that's also true. So D is a true statement as well. So C and D true, A and B false. Let's look at number 15. So x squared plus 2x plus 4, we're going to solve that using the quadratic formula. So we did that right before break. So the formula is x equals opposite of b plus or minus square root of b squared minus 4ac, all that divided by 2a. The equation x squared plus 2x plus 4 has an A value of 1, a B value of 2, and a C value of 4. So we're going to substitute those numbers in for A, B, and C in that formula. I like to figure out what the discriminant is first. So B squared minus 4AC. B is 2. A is 1. C is 4. 2 squared is 4. And then negative 4 times 1 is negative 4. Negative 4 times 4 is negative 16. 4 minus 16 is negative 12. So that is the number under the square root. So at this point, since the discriminant is negative, I know the solution is going to be imaginary. So at this point, I can eliminate B and I can eliminate D because those are all both real. It's either going to be A or C. Negative 12 is under the square root in the formula. So let's figure out what that is. I can simplify negative 12 by breaking it down into negative 1 times 4 times 3. The negative 1 because it's negative, and then 12 itself is not a square, but 4 is a square factor. So when I simplify that, square root of 4 is 2, square root of negative 1 is I, and square root of 3 is going to stay square root of 3. The rest of the formula around it is the opposite of B plus or minus that divided by 2A. The opposite of B is negative 2 plus or minus 2I square root of 3, all divided by 2A. A is 1, so 2A is 2. Since I can divide out of that negative 2, the 2I and the 2, I will. So this becomes negative 1, this becomes I, and this becomes just 1. So you end up with negative 1 plus or minus I square root 3. And that is answer choice C. All right. The only difference is, it is both A and C. It is both A and C because you got the plus and the minus there. So negative 1 plus I root 3 and negative 1 minus I root 3. So yeah, it's both answers there. Number 16 is also using quadratic formula. So we're going to do this just the same. You have x squared plus 5x plus 1, b squared minus 4ac. 5 goes in for b, so 5 squared minus 4 times a, which is 1, and c, which is also 1. 5 squared is 25, minus 4 times 1 is negative 4, times 1 is negative 4. So you get 21. So 21 is what's under the radical. That can't get simplified further. 21 does not have any square factors. It's only factors of 3 and 7, which are not square. So it will stay square root of 21. So C is your answer. I can already tell because that's the one that has the 21, square root of 21s. But if I build the rest of the formula around it, opposite of B is negative 5 plus or minus square root of 21 over 2A, which is 2. I can't simplify that further. So C is your answer. Let's look at number 17. Number 17 is asking to, all right, you're launching a toy cannonball from a platform. Does that ball reach a height of 34 meters? So we can use the discriminant to answer that question. You're first going to write the equation. So negative 5t squared plus 30t plus 8 equals, that h of t, we're going to substitute in that 34. So you have the equation of something getting thrown, launched, whatever. So ball, rocket, whatever. Does it reach a certain height? You substitute that number on the other side. So your answer to part A, just the first step is all it's asking you to do for part A. The answer to that is B. Okay, because we substituted that 34 into the other side of the expression or the equation that was given. Now, in order to answer the question yes or no, we're going to subtract that 34 to the other side. So you're going to end up with negative 5t squared plus 30t minus 26. I'm going to now find the discriminant of this. Very simply, if the discriminant is 0 or positive, the answer is yes, the ball can reach 34 feet. If the discriminant is negative, then the ball cannot reach that height. So let's find out what the discriminant is. We're going to substitute 30 in for B, negative 5 in for A, and negative 26 in for C. 30 squared is 900. Then negative 4 times negative 5 is 20, and 20 times 26 is negative 520. So 900 minus 520 is 380. That 380 is a positive number, so the answer is yes. If 380 was negative, then the answer would have been no. And 0 counts as yes if it was 0. All right, we're looking pretty good on time. I don't want to hold you guys up, but we have 3 questions left. What value or values of B will cause that equation to have one real solution? So we're also going to use the discriminant to answer this question. Recall that the discriminant is 0 when there is one real solution. So if I rewrite the equation, 3x squared plus bx plus 3 equals 0, b squared minus 4ac is equal to 0 when there's one solution. So B, I don't know what B is. That's what I'm going to have to solve for. But A is 3 and C is 3. So B squared, negative 4 times 3 is negative 12. Negative 12 times 3 is negative 36. I'm going to add 36 to both sides. And I get B squared is equal to 36. Take a square root of both sides. And I get that B is equal to plus or minus square root of 36. Square root of 36 is perfect square. So B is equal to positive or negative 6. So 6 and negative 6. So C and A are both your answers here. So positive 6 and negative 6. If the question was asking what values of B give it 2 real solutions, you would say B squared minus 4AC is greater than 0. And what gives you 0 real solutions or 2 imaginary solutions, you would say B squared minus 4AC is less than 0. So yeah, you would solve it that way. All right, number 19. Actually, I need to use this. Determine the number of real solutions for the system. We're going to graph this. Where they intersect, or how many times they intersect, is how many solutions you're going to get. So the first one is y equals x squared minus 4. The other one is y equals negative x minus 5. So if you see here, they don't intersect. So there are 0 solutions for this system. If they touched at exactly one spot, like that line touched that curve at exactly one spot, there'd be one solution where they touch. If that line crossed through and it touches it twice, then there'd be 2 solutions. There's no way a line can touch a parabola 3 times, so the answer to a question like this will never be 3. The only options are 0, 1, or 2. All right, and then for this one, it's giving you this big, long equation and asking you to solve it. So 5x squared plus 3x minus 14 equals negative 1/3 x plus 4. What it's suggesting is to make a system. So rewrite it as 2 separate equations. So the left side, y equals 5x squared plus 3x minus 14. And the right side, y equals negative 1/3 x plus 4. Take those 2 equations now. We're going to graph them just on Desmos like we just did. And where they intersect will be the solution. So y equals 5x squared plus 3x minus 14. Then negative 1/3 x plus 4. So those two solutions are where they intersect, and specifically for this question, I care about the x values. So the first x value is negative 2.26, and then I think it said to round to the nearest hundredth, so 1.59, and that would round to, it would stay 1.59. So the answer choice here would be negative 2.26 and 1.59. So that is how you would solve that one, right? Just split up that big equation into two smaller equations, see where they intersect. Where they intersect is the solution.